With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
Hello everyone, today we are going to solve this question. The question says that a capacitor of capacitance 12 mu farad is connected to a battery of EMF 6 volts and internal resistance 1 ohm through resistanceless leads. 12 mu seconds after the connections are made, what will be the A. current in the circuit, B. the power delivered by the battery, C. the power dissipated in heat, and D. the rate at which the energy stored in the capacitor is increasing. So this question has 4 parts. We are going to look at the information which is given to us. So when we are considered given, we have been given the capacitance, which is C, which is given to be 12 mu farad. Mu is 10 raised to power minus 6. So it will be 12 into 10 raised to power minus 6 farad. That is the capacitance of the capacitor. Then we have the voltage of the battery, the EMF, which can be denoted by V, which is 6 voltage. Resistance is given to be, the internal resistance is given to be 1 ohm. So the value of R is going to be 1 ohm. And finally we have given the time, which is small t, as 12 mu seconds, which can be denoted by 12 into 10 raised to power minus 6 seconds. Now we have to find firstly the current in the circuit. So for current we have a simple formula. We are going to consider part A, and our formula for current is I equals to I naught E raised to power minus T upon RC. This is the formula that we use. But for here we don't know the value of I naught. I naught can be found by simply creating Q, the charge upon time. And charge formula is C into V upon T. So this way we can find the value of I naught. We can put in the values. We know the value of C, which is 12 into 10 raised to power minus 6. For V it is 6. And for T it is 12 into 10 raised to power minus 6 again. So our I naught is going to be equal to simply 6 ampere. Now we have the value of I naught, and other values we already have. We can put those values in the formula. So I is going to be equal to I naught, which is 6 into e raised to power minus t, which is minus t is 12 into 10 raised to power minus 6 upon resistance is 1 and value of capacitance is 12 into 10 raised to power minus 6 again. When we calculate it further, I is equals to 6 into e raised to power minus 1, which is 6 into 1 by e. So the value of e that we have, when we put in that, then our total is going to be the value of first part, which is the A part, is going to be I equals to simply 2.207 ampere. This is our value. For our second part, we have the current. We have taken that out, so we can simply take out the power. So power can be taken out by a simple formula we have. Let us consider part B, power delivered. So the power is going to be equal to V naught into I. So V naught is the voltage and I we have taken out in the first part. So power is going to be, can be noted by P, V naught I, and we'll put in the values. So P equals to V naught is 6 into I is going to be 2.207 ampere. So the power is going to be equal to, it will be in voltage, so it will be 13.24 watt. So this is the power that we have, which is going to be our answer for part B. So we can write part B, power is equals to 13.24. Then we have part C in the question. For that, we'll consider another formula. For part C, we need to find the power which is dissipated. So total power equals to power stored, the power which is stored, plus the power which is dissipated. From this formula, we are going to find the dissipated power. So dissipated power is going to be equal to, simply when we rearrange it, so power dissipated, this we can write here, will be equal to power stored, it will simply complete power minus P stored. So to find the dissipated power, we need to find the stored power, which can be simply taken out by the energy that is stored. So that for that we have a formula. Energy stored is denoted by E, and it can be taken out with the simple formula, which is C into V square. So we'll put in the values here. So C has the value of 12 into 10 raised to power minus 6 into V square. For V square, we know that V equals to V naught e raised to power minus T upon RC. We have the value of V naught. So we'll put in the value of V naught, and in this form we'll put in the value of V. So it is going to be 12 into 10 raised to power minus 6 into V naught square, which is 6 square into square of e raised to power minus 1, like we calculated in the first part. So the total value that we are going to get from this is going to be the power stored. So the power stored is going to be equal to energy stored upon time. We are given the time as 12 milliseconds. So we'll put in both the values. It is going to be 12 into 10 raised to power minus 6 into 6 square into e raised to power minus 1 whole square upon simply 12 milliseconds. So 12 into 10 raised to power minus 6 seconds. So our final answer is not going to be the P value stored. We have to subtract that. So the value of P stored is going to be equal to 4.872 watt. Now we have the stored value. For dissipated value, which is the final answer, P dissipated is going to be equal to total power which we have taken out, which is B part 13.24 minus our value, which is P stored 4.872. So the answer is going to be 8.368 watt. This is our answer for the C part. And lastly, we have D part, which we have already solved and we didn't realize. So here is the energy. And when we talk about the energy, it gives us the power, the rate. In the question itself, we were asked for the energy stored in the capacitor, which is what energy at what rate it is increasing. So we have P stored, which we have calculated, and that is going to be our answer for the D part. So P stored is equals to rate of energy at which it was changing. So it is equals to 4.872 watt. This will be our final answer. Thank you.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut app today.